Hey everybody, welcome to Level Pixel Level. I just want to show you a problem I was facing on a project a while ago and just how I solved it. I had a little fitting like this that needed to rotate on 3 axes, and I'll show you what I mean, where I needed to rotate on just this axis, the X for these 2 pieces, and then these 2 would rotate just on the Y axis like that, and this third piece would just sort of spin here on the Z axis. And I could have solved this just with object parents, just by parenting the objects to each other. And just parenting this to here, and then just basically locking out certain axes. So this one would only rotate here, this one would rotate like this, and then this one would just spin. Unfortunately, that wasn't going to work for this project though, because it all had to live under one rig. So I need to figure out an armature-based solution to this. So the first thing I did was actually add an armature, and then I just pointed the bone itself down the main axes of the piece here. And then I just duplicated 3 more bones. And I parented these pieces to my duplicates. So this one went to this bone here. This one went to this bone. And this one went to this bone here. So I had 3 individual bones here that could move the 3 pieces. And again, that would have been fine where I could have just animated those just to their desired rotation. But the idea is that one joint would actually rotate for all 3 and control all 3, just to make a really easy control for the animator to look at. The first thing I thought to try was actually rotation constraints. So I added a rotation constraint to this one, and that was going to work, but I only want it to rotate on one axis. Meaning if I rotate this control here, it's going to rotate on all 3. So I came to here and I locked out the X and the Z, and now that just rotates on the Y. So that works for that one. I added the same constraint to the second bone, and I just turned off the Z for this one because I thought I could just follow along with the main rotation like that, and then I could have the Y rotation like that. That was working out fine. And I did the same thing to the third one down here. I just added another copy rotation constraint. I just left all 3 on. So I thought this would be the end of it, where I could just rotate there, rotate my Z axes, but very quickly something was going wrong, where if I tried to rotate it on all 3 axes, I was getting a lot of sort of breaking happening. The first thing I tried was to flip all of the constraints to local space instead of world space, and that did help a little bit, but I was still getting some breaking happening with my rotations. It was not consistent and not giving me the desired results. What I noticed though was that my rotation order was in quaternion, and I decided to flip it to XYZ Euler, and I thought that this would work a lot better, and immediately did. So I had my X rotation here, and then it would attempt to spin on the Z, and something very odd would happen, and my Y would just cause it to break completely. Next, I tried to change my rotation order into something a bit more logical for this, where I wanted the Z to calculate first, then the X, then the Y. And you immediately see that it's different here. And this seemed to work on my main bone, where I could rotate the X, spin the Z axis, and the Y. Everything to this point showed me that this should work, that this should copy the constraints, but here's where the problem lies. The children bone that were using the copy rotation were still in quaternion space, so the copy rotation wasn't going to work correctly on them. I had to actually match the rotational space of my sort of main parent bone here. They all had to be ZXY Euler. So now I could rotate on my Y axis, on my X axis, and on my Z axis, all from one joint. Now I wanted to check if this was going to be stable sort of in all modes as well, so I duplicated this bone down and I parented all 4 to it. Now this one I could move in space, and I could rotate the entire contraption as a whole, and this controller would just be my rotation on it. And this worked really well. The key to this was to make sure that my rotation constraints were in local space, and that my Euler rotation order was the same across all the joints with those rotation constraints. So in this case, Z, X, Y, Euler. For that project I mentioned, I also had to stack these, which is just a matter of parenting them, but that's why I wanted it to be on one controller for each rotational set. I wanted to make it really easy for an animator or another artist to just grab this and just move one control and have to just click on one thing to kind of move this joint system. It can still move in space and rotate around in pose mode, or even in object mode, it's still stable. And if you look in the bone layers underneath the hood, you'll see all of the other joints sort of just following along and moving with this setup. By keeping it to just one joint for each rotational set, it saved about like 9 controllers that would have had to be added, and just basically boiled it down to about 3. And then you can also grab all 3 of these, do some really fun things where you can kind of rotate them around completely. Anyway, let me know if you have any questions in the comments below. Big thank you to my patrons for supporting me in this video. It's because of them that I can keep making these videos. Head on over there if you want early access to all my videos, and then some of the higher tiers, I've been doing some behind the scenes content and also some exclusive tutorials. For example, for my Oldham coupling videos a while back, I did a whole video on how I lit, comped, rendered the entire intro shot and how I achieved that lighting setup within Blender. Thanks for watching, and I'll talk to you next time. Bye-bye.